Hello guys, this is question 2.94 of the 8th edition of our book. So the probability that Tom will alive in 20 years is 0.7 and the probability that Nancy will be alive in 20 years is 0.9. So let me first write this given data here and let me represent Tom with T and Nancy with N so that Tom will be alive in 20 years. The probability of it is 0.7 and the probability that Nancy will be alive in 20 years is how much? That is 0.9. Okay. On the basis of it, we can also find out what? We can also find out that the probability that Tom will not be alive in 20 years, that would be 1 minus 0.7 because that is basically the complement of this probability. So 1 minus 0.7 is 0.3, and similarly the probability that Nancy will not be alive in 20 years would be 1 minus 0.9, so it would be 0. Okay, so we have found out these two probabilities as well. Remember, both the events are independent of each other. What is the probability that neither will be alive in 20 years? Okay, so we have to find out what here. The required data is what? In terms of mathematics, what do we have to find out? That neither T nor N will be alive in 20 years. So that is probability that neither Tom nor Nancy, okay, nor for and or nor we have used this intersection symbol, we have to find it out. Okay, so we have to find the probability that none of them will be alive. Now in order to find it out, we have to find the solution. So its solution is here, and we have previously seen that this is basically the problem related to the independence of events, according to which if two events A and B are independent of each other, their combined probability would be the probability of A multiplied by the probability of B. Okay, so this is the probability of A and B. Now in order to find out this one, that probability that neither T nor N will be alive in 20 years, that would be 1 minus probability that both will be alive in 20 years. Okay, so in order to write it in the form of mathematical equations, what we can write here, this would be A complement intersection B complement, so it would be 1 minus probability of A and B. Okay, and we can see that as A and B are independent of each other, so therefore this one can be written as what? This one can be written as 1 minus probability of A multiplied by the probability of B. Here we can very clearly see that A is Tom and B is Nancy, which were previously T and N. Okay. So now putting their values here, because this is now P of T, this is now P of N, and also here we have seen that this one is this one. Okay, so now putting their values here, what would we get? We would get A complement and B complement. It would be 1 minus probability of A is 0.7 and probability of B is 0.9. Okay. So now 1 minus 0.7 and 0.9, it would be 63 divided by 100. Okay, or 1 minus 0.63, so it would be what? It would be 0.9. 37. Okay, so what is this? This is the solution of the question which is here. Okay. So that is the solution which we wanted to see. So this is what this one is the solution, and this is the answer of it. So that's it for today, in which we have seen the independence of the two or more events, in which the probability of the two events or the combined probability of two events can be calculated by multiplying the probabilities of the single event. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.95 of the 8th edition. Okay, so previously we have solved question 2.94 of the 8th edition, and in this question we are going to solve the same from the similar editions. So the statement it has is: one overnight case contains 2 bottles of aspirin and 3 bottles of thyroid tablets. Okay, so the first case basically consists of 2 bottles of aspirin and 3 bottles of thyroid. Okay, and the second tote bag contains 3 bottles of aspirin, 2 bottles of thyroid tablets, and 1 bottle of laxative tablets. Okay, so these are basically the 2 bags which are composed of these bottles of tablets. If 1 bottle of tablet is taken at random from each piece of luggage, find the probability that. Okay, so before going to find the probabilities or the required data, let me first explain it to you that what is the scenario here. So basically there are 2 bags. Okay, this is a first bag and this is basically a second bag. Okay, let me call it bag 1 and this is bag 2. In these bags, in first one we have 2 bottles. The first one is of aspirin. Okay, so this is what, this is the aspirin, and the thyroid one as well. Okay, so this is the aspirin and thyroid, and let me call them, this is aspirin, so let me call it A1, and this is T1 because of the thyroid. And how many bottles of aspirin are here? So there are basically 2 aspirin and 3 thyroids. Okay, similarly in the second one we have 3 bottles, and these 3 bottles are, let me, 1, 2 and 3. Okay, the first one here is the aspirin. This is, let me call it A2 because of the second bag here. Similarly 2 bottles of thyroid, so this is T2, and the third one is 1 bottle of laxative tablets. Okay, so laxative is 2. Okay, so how many bottles do we have here? So a second bag contains 3 bottles of aspirin, so 3 bottles of aspirin, 2 bottles of the thyroid tablets, and 1 bottle of laxative. Okay, so this is basically a given data which we have, and in the section containing the given data we can also write here what. Okay, we can also write that A1 is 2 and T1 is 3. Okay, on the basis of it we can also find out their probabilities. So the probability of A1 is the number of bottles of A1 in bag 1 divided by the total number of bottles. So basically we can see here that 2 plus 2 is 5, so the probability of it is 2 by 5. So the probability of the selection of A1 is 2 by 5. Similarly, the probability of the selection of T1 is the number of T1 bottles in bag 1 divided by the total number of bottles. So this is 3 by 5. Okay, so this is for what? This is for the first bag. Okay, for the second one, let me use this color. So for the second one we have A2 equal to 3, T2 equal to 2, and there is also this L2 which is 1. Okay, so this is 1, this is for the second bag. Okay. Now in order to find the probabilities associated with each of them, is the probability of A2 is the number of bottles of A2 divided by the total number of bottles. So this is 3 bottles, and 3 plus 2 plus 1 is 6, which is also 1 by 2. Okay, similarly probability of T2 is 2 divided by 6, which is also 1 by 3, and probability of L2 is the number of L2 bottles divided by the total number of bottles. This is 1 by 6. Okay, so this is the overall data. Why am I giving this much time to the given data and the required one? Because in these type of questions, if you have a clear picture of all the required ones, all the given data, and you have transformed them to the probabilities or in the mathematical terms, you can very clearly find the relevant formulas, relevant strategy to sort out what is required and what you have to do. Okay, so now what do we have to find out the required one? Let me write the required one here. Okay, so the required one are, in part A, what is required? Both bottles contain thyroid tables. Okay, we have to find the probability that both bottles which have been selected at random contain the thyroid tables. So in other way, it can be the first bottle would be T1 and second bottle should also be T1 here as well. In B, what is it asking us to find? That neither bottle contains thyroid tablets. Okay, so what it would be? It would be neither thyroid nor thyroid in the second, and this is the required one for the second one. And in C, the two bottles contain different tablets. Okay, so if one is thyroid, the other one shouldn't be thyroid, or if one is aspirin, the other one shouldn't be aspirin, and vice versa. Okay, so this type of question. So now let me write it here, that 2 shouldn't contain the 1. So if A is the first one, then the second one shouldn't be this one. Okay, so we have to find this one, these required things here. Now in order to solve them, let me solve part A first. Okay, so in order to find the probability of T1 and T2, what do we have to find here? As we can very clearly see that these two events are basically independent of each other. Okay, so here this is for the first bag, this is second bag. If one bottle has been selected from 1 and the second for 2, these two are completely independent of each other because these are separated out. So therefore we can clearly see that the probability of T1 and T2, this is basically a case of the independent probabilities, where this one would be the probability of T1 multiplied by the probability of T2, which is the required formulation for the independence of event. Now let me put their values. So probability of T1, that is already given, this is here, and probability of T2 is also given here. So let me write their values, and it would be 3 by 5 multiplied by 1 by 3. These two will cancel out, and ultimately I will get here 1 by 5, which is the answer of the part A. Okay, so this is the required answer for part A. Part B, we have to find that neither bottles contain thyroid tablets. So probability of neither are same. It can also be found out by 1 minus probability that both are same. Okay, so if I want to find out the probability that both should not contain the thyroids, what can I find it out here? I should have to subtract it from probability that any one of the terms will contain the thyroids. Either it can be the first one, either it can be the second one, or it can also be the two ones as well. So that is basically the union operation. So therefore I have to write here T1 or T2. Okay, because in this scenario or in union, if any one of them is 1, so it will give me output equal to 1, because this is union, or in digital fundamentals term I can also call it the OR operation. Okay, so let me write them here, and I know that probability of the two events, if I have probability of A union B, So I can find out this probability by probability of A plus probability of B minus probability of A intersection B. Okay, this is the rule which has been made. So now putting or applying the same rule here, what would I get? I would get here probability of T1 plus the probability of T2 minus probability of T1 and T2. Okay, so these are the probabilities which I have to find out. So let me now remove this equation from here so that I can write all the values which are associated with them. So now it would be 1 minus probability of T1 is given, and that is here 3 by 5. Okay, so 3 by 5 plus probability of T2 is 1 by 3. Okay, and probability of T1 and T2 we have found out in our previous part of this question, and it was 1 by 5. Okay, so when it is calculated and then subtracted it from 1, 11 by 15, which ultimately give me 4 by 15, and that is the solution of part B. Okay, so that is what we have to find out, and the solution of it was 1 by 5, where its solution is 4 by 15. Now let me proceed towards part C. In part C, we have to find that neither of the bottles should be similar. Okay, so in order to do so, as we have been selecting these bottles from the two different bottles, so therefore now let me represent them here as a single one. Okay, and here what would be our strategy? Here I want to find out the probability that neither of them will be the similar. So the probability of it would be A and prime, it would be the total number of different combinations or permutations divided by the total possible combinations. Okay, so here we have to find it by using this formula, and let me call it equation A. Now in order to find the total number of possible permutations, what it would be here, so here if we consider it as a single box, so here we have 5 items, and out of these 5 items I have to select any 2 items. Okay, so this can be a case of the permutation. Okay, so we can find out here by NPR, where the total number of permutations are n factorial divided by the n minus r factorial, and r factorial are the selected ones. So let me put n equal to 5 because it 2 items here in first box, 3 in the second one. I will get here 5. So 5 factorial divided by, I have to select any 2 from them. So here I will get 5 minus 2, it would be 3 factorial, and r is what? R is again 2. So here we have this case. So let me also write it here. Here n is 5 and r is 2. Okay, so now solving it and then finding it out, what I will get here, I will get this equal to 10. If you find it, you will see that this is equal to 10. So the total number of permutation I can get from this scenario is 2. Okay, so now in order to find the different number of combinations which I can get here, either it can be A1 T2, either it can be A1 L2, either it can be T1 A2 or T1 and L2. Okay, so both of them cannot be similar. I mean A1 A2 is not possible, T1 T2 is also not possible. So in order to find them out, what do I have to do here? Again, I have to use this slot concept. So in this slot concept, what I have to do here, I have to find the classes. So I have here 3 classes. First class is aspirin class, the other one is the thyroid class, while the third one is the laxative class. Okay, so I have 3 classes. For the first slot here, I have to select one class. Okay, so if there are 3 classes, I have to select or I will have 3 choices for the first slot. Okay, for the second slot I cannot select the same class which was previously selected, so therefore these total number of classes I have to select here had reduced from 3 to 2. Okay, so this is 1, this would be 3 multiplied by 2, because each of the class will be associated with the other 2 classes, so this will give me 6. Okay, so this is what, this is the different number of combinations I have to find out. So now putting these values, because this is what, this is the total number of possible combinations, and these are basically the different combinations I have to find out. Putting them here in equation A, what I will get, let me use this color for it. So what I will get here, I will get here probability of A, and A prime, this would be 6 divided by 10, which will ultimately give me 3 by 5, and that is what, that is the solution of part C. Okay. So you have seen that from the very fundamental equation here, which is the fundamental equation for the probability and random variables, I have found out the probability that the two selected bottles are different from each other, and for that case I have basically considered the number of classes I have here, and these classes are the tablet name which I have been using here. Okay, so I think it's enough for today. If you have any question, you can always ask me in the comment box. See you soon.